Welcome to Wildcat Science with Mrs. Haugo. This is Chemistry, Chapter 6, 6.3, the valence electrons. So please write this down. Electrons, the valence electrons, are electrons in the outer shell. And those are the ones that are responsible for making chemical bonds. And another really important concept is elements with the same number of valence electrons have similar properties. So you want to put that into your brain. And elements with the same number of valence electrons can form similar compounds. They react in a similar way. So you want to make sure that goes in your brain too. Okay, so we know that sodium and lithium are in the same family. They're in group 1. They're both alkali metals. And they're going to form 1-to-1 ratios with halogens. So NaCl and LiCl. Whereas magnesium we know is group 2, and then oxygen and sulfur are both in the same group. They're in group 16, the oxygen family, and they're going to form 1-to-1 ratios with sulfur and with oxygen. And when we're looking at valence electrons, we're looking at our main group elements, and these are the S and P blocks. We're looking at groups 1 and 2, skip a few, groups 13 through 18. Let's dive into what we wrote down just a little bit more. We see that oxygen and sulfur are both in the same group, both in the same column on the periodic table, group 16 of the oxygen family. So we know they're going to have similar chemical properties. We can also see that they have the same number of valence electrons. Oxygen has 6, 2 S's, and 4 P's for a total of 6 outer electrons. That's in the second shell. And then sulfur in its third shell has 2 S's and 4 P's for a total of 6. So the 6 valence electrons is much more important than what shell it's in. So they're going to have, if they're in the same family, they're going to have the same number of valence electrons, they're going to have similar properties, and they're going to form similar compounds. So we know that oxygen and sulfur are in the same family, and we can see when we pair them up with aluminum, aluminum sulfide is Al2S3, and aluminum oxide is Al2O3. The same thing happens when we pair them up with magnesium. It's a 1-to-1 ratio for both. If we pair them up with carbon, it's going to be a 2-to-1, so 1 carbon to 2 sulfide. Same thing with oxygen, carbon dioxide, CO2. When we pair them up with sodium, a group 1 metal, it's a 2-to-1 ratio, Na2S. Same thing with oxygen, sodium oxide, Na2O. So how do we find the valence electrons? Well, one way is to look at the periodic table, and in class we'll review how we do that. Group 1 is 1, Group 2 is 2, Group 13, 3, 14, 4, 15, 5, 16, 6, 17, 7, and 18 has 8 valence electrons. Another way is to count the highest S and P electrons. So, how many electrons does tin have? To clarify, let's say valence electrons. So how many valence electrons does tin have? And if you said 4, you would be correct. One way of looking at this is knowing it's in the group 14, so that means it has 4 valence electrons. Another way is looking at its highest S and P electrons. And we will do that momentarily. Please write this down. So this is for the S and the P, the main block elements, S and P block elements. For the transition metals, the D block, you're going to have to look at the oxidation numbers on the periodic table. Okay, so looking at our main group, our group, not our main group, but our D block, we can see, and yours is going to look, your periodic table look a little bit different, but they have oxidation numbers here. Often in the upper right, and so iron can have a +2 or a +3, nickel, same thing, copper can have a +1 or a +2. So looking at the electron configuration of tin, it would be 1s2, 2s2, 2p6, 3s2, 3p6, 4s2, 3d10, 4p6, 5s2, 4d10, 5p2. So the highest S and P would be 5s2 and 5p2. 2 plus 2 is 4, so it has 4 valence electrons. Let's try this again. Please write down the full electron configuration for chlorine. If you wrote down 1s2, 2s2, 2p6, 3s2, 3p5, you would be correct. Good job. Now we're going to look at the highest S and P orbitals. So maybe you could circle them on your paper. And we have 2 in 3s and 5 in 3p. 2 plus 5 is 7. Chlorine has 7 valence electrons. So you want to write 7 valence electrons. Okay, please write down the electron configuration for gallium. If you did 1s2, 2s2, 2p6, 3s2, 3p6, 4s2, 3d10, and 4p1, you would be correct. And then we look at our highest S and P orbitals, which is 4. 4s2 plus 1, 4p. 2 plus 1 is 3. Gallium has 3 valence electrons. And indeed, it is in group 13, which we know does have 3 valence electrons. So you want to circle 4s and 4p, and then write down that they have 3 valence electrons. Okay, so you wrote this down in chapter 5 or an earlier chapter. If you need a refresher, go ahead and make a go ahead and put this in your notes. You don't have to, but if it would help you, you should do that. It is just like an outline of the periodic table, and then group 1 has 1 valence electrons, 2, 2, and then over here, group 13, 3, 14, 4, 15, 5, 16, 6, 17, 7, and 18, 8. You may be wondering about the A's and the B's. Some periodic tables do just number the main group, the S and the P orbitals, but I think that's a little bit confusing to have A and B's, so we always, we just do 13, 14, 15, 16, 17. It's 2 different ways to write it. Both are correct. Question for you is, how many valence electrons does magnesium have? If you said that it has 2 because it's in group 2, you would be correct. Let's look at another one. We have selenium, and this is the electron configuration for selenium. 1s2, 2s2, 2p6, 3s2, 3p6, 4s2, 3d10, and 4p4. So the filled d orbitals do not contribute to valence electrons, only the outer s and p. So these are all filled, they're not valence. This d is filled, it's not valence. So we take our outer 4s and our outer 4p. 2 plus 4 is 6. It has 6 valence electrons. And indeed, it's in the same group as oxygen, which is group 16. So it'll have, figuring it out that way, it would also have 6 valence electrons. Okay, how do we do Lewis dot diagrams? These are going to be pretty useful. So what we do is it's a diagram showing the valence electrons and the atomic symbol. So please write this down, Lewis dot diagrams, Li with 1 dot, 1 valence electron. Beryllium has 2 dots. You see we're just going around. I like to go around clockwise. This one, the book goes around counterclockwise. It doesn't really matter. Boron has 3. Carbon has 4. And now 5, nitrogen, we're going to start doubling up. Now when each of the 4 sides has 1 dot, then you can double up. So nitrogen has 2. Oxygen has 6, so 2 sides are doubled up. 2 sides just have 1. Fluorine has 7. And neon has 8, 2 on each of its 4 sides. Now I would like you to draw the Lewis dot diagram of phosphorus. If you made a P with 5 valence electrons, you would be correct. Good job. Okay, we're always talking about the valence electrons because they're very important in chemistry and chemical bonding, because valence electrons are the ones that participate in bonding, in chemical bonds, because they are the most loosely held electrons. So please write that down. Okay, you don't need to make this diagram if you pay attention. You can see when we're looking at just the S and the P blocks that there's a really strong pattern for valence electrons. Everything in group 1 has 1 valence electron. Group 2, 2, 3, 3, 13, 3, 14, 4, 15, 5, 16, 6, 17, 7, and 18. Helium has 2, which is a filled outer shell, and then 8 for our noble gases. You can see the valence electron causes similar bonding patterns. So when these group 1 elements are bonding with oxygen, it's always in a 2-to-1 ratio. Whereas in group 2, it's always going to be in a 1-to-1 ratio. Group 3, it's going to be in a 2-to-3 ratio. 4, a 1-to-2. Group 15, with 5 valence electrons, is going to be a 2-to-5 ratio. Group 16, it's going to be a 2-to-1. And now this one's bonding with, we're having it bond with hydrogen, because these are nonmetals here. And then with hydrogen, the halogens are going to be a 1-to-1 ratio, and then these don't bond. All right, so let's talk about carbon. How many valence electrons does carbon have? Please make its Lewis dot diagram. If you said it has 4 valence electrons and you made your Lewis dot diagram like this, you are correct. Okay, looking at the chemistry in context, please write this down. Group 1 and 2 elements in your body. So when you read these pages, I want you to be able to answer these questions. So groups 1 and 2 elements regulate nerve impulses, heart muscle contractions, proper water balances. They're super important. So a question for you is on page 190 and 191, what do sodium and potassium and nerve impulses all have in common? How are they all related? And what can you tell me about calcium ions and muscle contractions? You should be able to answer this not just from reading, but from human biology. Same for this one. What can you tell me about electrolytes? Why are ions in the blood plasma important and the extracellular fluid? What can you tell me about lithium and a medication for mental disorders? In summary, elements that belong to the same group in the periodic table have the same number of valence electrons. Only the valence electrons are involved in chemical bonding. A Lewis dot diagram is a really great way to show valence electrons. And there's an example of a Lewis dot diagram and a electron configuration showing our highest level S and P valence electrons. And that concludes our Chapter 6 notes. Good job. Bye.